Welcome to Ask and Learn.
Hello student, in this problem a model of transmission line is given and where the value of source voltage Vs equals to 115 angle of 0 degree volt and the value of series impedance Zs equals to 1 plus iota 0.5 ohm and the value of line impedance ZL equals to 0.4 plus iota 0.3 and the value of load impedance ZL equals to 23.2 plus iota 18.9 ohm. Okay, now we have to find out the value of load current IL. We have to find out value of the load current IL. So we know that the load current is given as IL equals to Vs upon Z, where Z is the total impedance of line. Total impedance of line. So first we have to calculate the total impedance of the line. Okay, so Z equals to here series impedance is Zs, source impedance is Zs plus line impedance ZL plus load impedance ZL plus again series line impedance ZL. Then effective impedance Z equals to Zs plus 2 ZL plus load impedance ZL. Okay, so now put the value in this equation. Zs equals to 1 plus iota 0.5 ohm plus ZL equals to 2. Line impedance is 0.4 plus iota 0.3 ohm plus load impedance is 23.2 plus iota 18.9 ohm. Okay, so the effective value of load impedance, total impedance Z equals to 1 plus iota 0.5 plus 0.8 plus iota 0.6 plus 23.2 plus iota 18.9. Okay, so now total impedance Z equals to sum of the real value 1 plus 0.8 plus 23.2. So the effective value is 25 plus and the summation of this part. Okay, summation of this part. So it is iota 20. So this is the complex form. So if we convert it in polar form, then the value will be 32.02 angle of 38.66 degree. Okay, the impedance in polar form can be calculated by using the formula A plus iota B equals to square root of A square plus B square. This is the magnitude of this quantity and angle is given by tan inverse B upon A. Okay, so now we have to calculate the value of load current IL. Then the IL is given as V upon Z, where Vs equals to 115 angle of 0 degree upon impedance Z equals to 32.02 angle of 38.66 degree. Okay, so now divide 115 by 32.02. The value will be 3.592, and if you shift the angle in NS term, then it is minus 38.66 ampere. Okay, so this is the resultant load current across the load in given transmission line circuit. So in this problem, what we have to First we calculate the total impedance Z by using this formula, the series combination of all the impedance. Then the load current IL is given by Vs upon Z, where Vs is the source voltage and Z is the total impedance. This is given by 32.02, angle of 38.66, and the resultant current will be calculated this one. Thank you.